Today, let us learn about the domain and the range of some square root functions. This symbol that you see here is called a radical symbol. And what comes inside of it, the expression that comes inside of it is called a radicand. So, in this case, what is your radicand? Your radicand is x minus a. Now, the radicand of square root functions comes with a very important restriction. This expression that you see here, this radicand that you see here cannot be negative. At all times, it has to be greater than or equal to 0. So, what we are going to find first is the domain. So, what is the domain? Your domain will be the collection of all the x for which your x minus a is greater than or equal to 0. So what all numbers are we talking about? If you consider this particular example, which is x minus 7, right? So I will take this one. So x minus 7, we are looking for all the numbers for which this is positive. So what are we talking about? There can be 8 and 9 and 10 and all of that. What can this domain not have? This domain cannot have, say for example, it cannot have minus 1. Why is that? Because instead of this x, if you put minus 1, what is the term you are getting? You are getting minus 8. That means we are talking about square root of minus 8. Now, why is square root of minus 8 a problem? Are we doing anything illegal? Of course not. What we have is that the square root of a negative number is not a real number. It lives in another world. It lives in an imaginary world. This becomes a complex number. It is not a real number. We have a problem there. We don't want complex numbers. That is why we cannot have a negative radicand. That is the only restriction that we have. So in each of these cases, we are going to restrict our domain. We are going to restrict our x so that our radicand is positive, and according to that domain, we are going to find the corresponding range. And another one very important thing you have to remember here is that you cannot have a negative radicand for a square root function, and not just for a square root function, for the fourth root, for the sixth root, for the eighth root, you cannot have a negative radicand. But at the same time, if you are thinking of cube root of minus 8, absolutely no problem. Why is that? Because the cube root of a negative number, you will get an answer. What is it? It is minus 2, right? Minus 2 cube is what? It is minus 8. And what do you know about minus 2? It is a real number. So you see this restriction, this domain restriction, that the radicand cannot be negative, is only for square root functions, not just for square root functions. Any even root, there's the square root, fourth root, sixth root, we need to have only positive radicands. We cannot have negative radicands. But then if we are dealing with cube root, absolutely no problem. It is completely legal. Now shall we start the class? Now this is our first function. What sort of a function is it? It takes every real number x and maps it to square root of x minus 4. Then tell me, what is 4 mapped to? 4 gets mapped to 0. What about 5? 5 gets mapped to 1. Square root of 5 minus 4, we get 1. And what about 6? 6 gets mapped to square root of 2, which is what? 1.4 something. So how does your graph look like? So your map looks somewhat like this. So what is going to be our domain? Our domain is going to be the collection of all the numbers x for which x minus 4 is greater than or equal to 0, or in other words, your x minus 4 cannot be negative. Now, when is the difference of two numbers positive? When the first number is greater than or equal to the second number. So, we will take only the numbers which are greater than or equal to 4. Anything less than that. When is a number less than in the number line? How do you know some number is less? When it comes to the left of 4. Now all the numbers to the left of 4, you can forget it. It is not included in the domain. Our domain starts from 4, and where does it end? It goes all the way. It goes and goes till the kingdom comes. So all the way to infinity. Now what you have is two different types of notation. Now you have two different types of notation for the domain. This one is called the inequality notation, and this is called the interval notation. Both of them mean the same thing. Both of them mean that your x, it has a lower limit. It stops at 4. It cannot go below 4. It can go above 4 as much as you want. Up till infinity, you are free to choose whatever number you want. So there are two different types of notation. Both mean the same thing. Another important thing to notice is this symbol that you see here. This means it is closed. What happens when a room is closed? Somebody who is inside stays inside. So this means that 4 is included. This closed interval means that this is greater than or equal to 4. Suppose if you have x is strictly greater than 4, then the symbol you will use is this. This is what we call a open. This is the sign for an open interval. This is the sign for the closed interval, and means that 4 is also included. Now what is the range? The range is the collection of all the y for which you can find a pre-image. F of x should be equal to y. Every y should have an x. We are going to take the collection of all those y. Or in other words, what we are going to find out is, do we need this entire axis all the way from minus infinity to infinity? Do we need all of these numbers, or is there going to be a restriction? Just one look at the graph will tell you. Your y is not coming below this 0. It is stopping at 0. If you see this domain, it starts at 4. The lowest number that the domain can have is 4. And corresponding to 4, your y is what? 0. So you can see that this y is not coming anywhere down. It is stopping here. So therefore, your domain starts from 4 and your range starts from 0. Now every time we have a function, we cannot keep on drawing the graph, right? So we will just use this domain restriction. We will use a restriction for the domain and try to find the corresponding range. What is the restriction for the domain? Your radical has to be always greater than 0. If a number is greater than 0, then what do we know? Its square root will also be greater than or equal to 0. But what is this? This is actually our y. So what are we saying? Our y always has to be greater than or equal to 0. But this is the inequality notation. How does the interval notation look like? It is a closed interval all the way from 0 to infinity. So your range always has to be 0 to infinity. Now we have taken 4. It is true for any number that you can think of. Now look at this function. You can write it as square root of x minus f. So what is your a here? Your a is actually minus 5. You can just randomly check. Put minus 5, it gets mapped to 0. Put minus 4, it gets mapped to what? 1. And put 6, It gets mapped to square root of 11. So our domain is this. And what is the range? And without going through all those steps, you should be able to just look at it and say, if this is your function, this will be your domain, and your range will be what? 0 to infinity. This is a standard type. Now, what happens if this same expression comes in the denominator? Now the same term, when it comes in the denominator, there is a small change. The domain and the range in both the cases are pretty much the same, except for one very important difference. You see the difference in the intervals? You have a closed interval here, you have an open interval here. That means what? In this case, your x cannot be a. It cannot, you have to drop that a. Why is that? If your x is a, what happens? You have square root of a minus a, which is 1 by a. This is impossible. The maths police will catch you. You don't want to be doing that, because such a fraction with a zero denominator does not exist. It tends to infinity. So except for that, everything is going to be the same. So our domain is the collection of all of those x for which x is strictly greater than a. Please remember, we cannot have x greater than or equal to a, because that would mean square root of a minus a, which means you will get 1 by 0, which is not acceptable. We cannot have that. So our domain, what we are doing is that we are taking the entire x-axis, the entire real number all the way, and what we are doing is we are restricting it. We are saying that it has to be above a. It cannot come to this side. That is what we are saying. I have not taken any example here. You can put any real number you want, plus 17, minus 17, or any fraction or whatever you want. Any real number you can put in this place. And what your domain does is that it restricts the x-axis. Now, what does your range do? Your range, what it does is that it restricts the y-axis. All the y that this function can take. What we need is a limit for it. Just like we say that the x cannot go below a. Is there any number possible? Is there any number we can say that after this y will not go? Is there any number? That is what we have to find out. And for that, remember, you have to always start from your domain. Your range has to worry about only those numbers which are part of the domain. The other one is none of our business. So now what does the domain say? The domain says that all of your x is such that x minus a is strictly greater than 0. Now when a number is positive, its square root is positive. Now when a positive number is greater than 0, then its reciprocal will also be greater than 0. But then what is this number? This is exactly our y, our fx, which we had taken as y. So what have we done? We have got a limit for 0. We are saying that this y cannot go below 0. It cannot be a negative number. Now that is exactly what we got. Your domain looks like this and your range looks like this. As long as your x has a coefficient of plus 1, this is how you do this. X minus maybe 4 or a square root of x plus 7. In this case, you will take your a as minus 7 and your domain will be from minus 7 all the way to infinity, and your range will be what? 0 to infinity. Now, according to your question, you just change this type. Now, what happens if your x comes with a minus? For example, what about 4 minus of x, or what about minus 17 minus x? What if your x has a coefficient of minus 1? We will go to the next type and find out. Now we move on to our next type. We have a function which takes every x and maps it to square root of, here I have taken a to be 13. You can take any number in its place. We have taken a function which maps x to square root of 13 minus x. What is the domain? It is the collection of all the x for which this radicand is what? It is non-negative. That means it is greater than or equal to 0. But remember this same thing if it comes in the denominator. Suppose it looks like this. Then you will make the small change. Instead of greater than or equal to, you will put strictly greater than 0. Remember to make that difference. It is a very, very important difference. But here we are taking the numerator. That is why I am writing it is greater than or equal to 0. Now, when is the difference of two numbers positive? When the first number is greater than or equal to the second number, or in other words, when the second number is less than or equal to the first number. So now do you see the change here? Your 13 comes here. And we are saying that the domain contains all the numbers which are less than 13, which comes this way. Or in other words, 13 is an upper limit. It cannot have values above of 13. It has to be below 13. Then below means how low? Anywhere up to minus infinity, whatever you want you can take. So here this is your inequality notation. Your x has to be less than or equal to 13. Then what does your interval notation look like? Your x should belong to here 13. Now 13 should be the upper limit. And it contains all of these numbers. Now, one very good thing about this is you can always substitute values and check your answer. Randomly take a number from here. What about minus 14? Only minus 14 lies here. Remember, 14 lies to the right. In the number line, when you want greater numbers, go to the right. When you want lesser numbers, come to the left. So you have to take minus 14. 14 lies in this area that we have already crossed out. You cannot take this. Take minus 14 and substitute it here. What do you get? 13. Square root of 13 minus 14, which is what? Square root of 27. It is what? A positive number. So it is a real number. Now we have found that our domain is the collection of all the x such that x belongs to such an interval. Once you find the domain, according to it, you have to find the range. Your range does not have to worry about 14 or 15 or 100. Your range need not worry about all of that because your domain, it can go only up to 13. It cannot go to 14, so you do not have to worry about it. Now for this domain, we are considering all the x for which this radicand is always non-negative, or in other words, greater than or equal to 0. When a number is positive, its square root is also positive. But then what is the square root? It is actually y. So what is the important restriction that you have? Your y will always be positive. So in this case, you will notice that your domain, whatever your a is, I have taken 13 here. Whatever your a is, it will be minus infinity to a. Now, the same thing, if it comes in the denominator, then what happens? A very small but very important difference. Your domain has to be all of those x. The collection of all of those x for which 13 minus x is strictly greater than 0, not strictly greater than or equal to. Why is that? Because if your x happens to take the value 13, you will have 1 by 0 which you cannot have. So it is a strict inequality, or in other words, it is a collection of all of those x where x is what? Less than 13. When is the difference of two numbers positive? When the second number is less than the first number, or in other words, the first number is greater than the second number. Or in other words, your domain consists of all the numbers which is below 13. It should not go to 14. If you cannot have a 14 here, you cannot have a 15, 16, you cannot have values that. It should be less than 13. It should be to the left of 13. And where does it stop? Nowhere. All the way to minus infinity. So you see the important difference here. Here your A had a closed interval. Here it has an open interval. What about the range? Range also the same thing happens. Your range does not need to worry about 14 or 15. It just has to worry about these numbers for which 13 minus x is strictly greater than 0. If a number is positive, then what do you have? Its square root is also positive. Now, the reciprocal of a positive number is again positive. The reciprocal is again positive, but then what is this reciprocal? This is the exact y that we needed. So your y always has to be greater than 0. That is the only restriction that you have. Now for the last and the final type, what do we have? We have a function which takes every x and maps it to such a term. Now what is the domain restriction that we have? The restriction is only for the square root. Whatever comes inside the square root, your restriction is only for that. This is a constant. Constants are harmless. They are not going to affect you in any way. So what you need to find is the set of all the x, the collection of all of those x for which x minus 18 is non-negative. When is the difference of two numbers greater than 0? When the first number is greater than or equal to the second number. Or in other words, your x cannot go below 18. 18 is as low as it can go. And its upper limit, there is no such thing. It can take whatever. It can be 19, it can be 1 million, it can be 100, it can go all the way up to infinity. So this is what your domain is. So in such a case, whenever you see such a function, remember your domain is what? It is a to infinity. And what about the range? You remember what I told you? Your range has to depend on your domain. You do not have to worry about say 17 or 0 or 1. You do not have to worry about those numbers. Your range needs to worry only about what is in the domain. Or in other words, your range is only those y for which you can find a pre-image x. Or in other words, what is the condition for your x? Your x minus 18 should always be greater than 0. When a number is greater than 0, when a number is positive, its square root will also be positive. But then this is not our y. Our y has a plus 7 also to it. So what do we do? Add plus 7 to both sides. So plus 7 here and plus 7 here. But this is what? This is exactly what our y is. So now what is the limit for your y? Your y cannot go below 7. It cannot be a 6. It cannot be a 5. It stops at 7. So your y should be from 7 all the way to infinity. It should start from 7. It cannot be 6. It cannot be 5. It cannot go below this. So whenever you have such a function, you have to remember that your range is actually going from b to infinity. Can you tell me the domain and range of these functions without going to the usual circus of, greater than or equal to 0 and all of that? Just one look at it. Can you tell me what form it is and what will be your domain and range? What form is it? This is of the form a minus x. And what did we say the domain was? We said that the domain will have an upper limit a. It cannot be more than a, or in other words, it cannot be more than minus 4, and here it goes up to minus infinity. And the best thing is that you can always substitute values here and check for yourself if it is right. Put minus 4 here. What do you get? minus 4 minus 4, you will get 0. Randomly give me another number. What about minus 10? What will you get? You will have minus 4 minus x, we have taken minus 10, right? So it is square root of 6. So it is fine, right? Your radicand is not going to be negative. And what did we say the r was? The r, irrespective of it, your r was going to be 0 to infinity. You remember that? Now, what sort of thing do we have here? This is of the form x minus a. Right? Where what is your a here? Your a is actually minus of 13. X minus 13. So what is your domain now? Your domain, you should remember, it comes in the denominator, which means what? We should be dealing only with open intervals, not closed intervals like this. So what was our domain? Our domain actually started from minus 13 all the way to infinity. It could be anything. Randomly tell me a value from minus 13 or to infinity. 0 is here, right? Put 0 here. Does it work out? And what about minus 1? Minus 1, minus 2, minus 3. Any negative numbers from this onwards. Put minus 12, minus 11, minus 10, all of that. You will see that you are getting positive values for the radicand. And what about the r? The same thing. Your 13 plus x always has to be strictly greater than 0. That means if a number is positive, the square root of that number will be positive, and then what? The reciprocal of a positive number will always be positive. But what is this? This is exactly what our y is. So here your y is going to be 0, infinity. The usual thing. Just put values for that a as we know it. And now for the last question. So what sort of a function do we have? We have x minus of 3 plus minus of square root of this. So your a is what? Minus 3 here. Your b is what? Minus square root of 17 here. What did we say the domain was? This does not disturb the domain in any way. It's a poor constant function. It won't disturb you in any way. All you need is those x for which this is greater than or equal to 0, or in other words, those numbers above minus 3. That is what you need. Your a is minus 3. So this is how it looks. What about your range? Your range starts from your b, which is, oh, I forgot to put the minus here. So your b is actually minus root 17, because we wrote it in this form, x minus a plus b, right? This is the form we wrote. So we just have to bring this to our standard form. So it will be x minus of 3. That is what we have got here. Your b is minus square root of 17. So your r is going to be what? Its values is going to start from square root of 17 and go all the way. So that is all. So in this class, all our radicands were of degree 1. We just had x in all sorts of permutations and combinations. X plus a minus x in the numerator, in the denominator, but it was all of degree 1. Inshallah, in the next class, what we will do is we will graduate to these sort of expressions where your radicands will have the degree 2. But that is for another day. Till we meet again. Assalamu alaikum.